Hey there, the Networkberg here. Hope you're doing well. Welcome to the channel where I mainly cover stuff with MikroTik and MTCRE, MTCNA and all that stuff. And if you're a returning viewer, welcome back. So, what are we going to do today? Well, we're actually going to be wrapping off the MTCRE course that I've made. The thing is, I could probably make a few more videos where I specifically look at certain concepts, but I felt just making one mega video covering all of the VPN aspects I felt would work a lot better. So this might be a little lengthy, it might be 30 minutes to an hour or so, but I will put in timestamps in the video, so feel free to use the timestamps to skip to whichever portion of the video that you feel that you wish to learn from the most. And the stuff we'll mainly be covering is, we'll be looking at VPN concept, what it is. We'll be looking at stuff like how to configure an EOIP tunnel as well as an IPIP tunnel. And I also will be putting in some reference material in a comment to some of the other tunnels that I've already covered in the MTCNA. I will put those videos in the playlist, but they were made specifically for the MTCNA, but it still functions exactly the same. The stuff that you need to know for triple PoE doesn't change between MTCNA and MTCRE. It's still triple PoE, so I'll just put in those links so that you can visit those videos if you specifically want to see how to do PPPoE, L2TP, PPTP or SSTP. Anyways, enough talk. Alright, so let's just do a quick brief presentation so we can just discuss VPNs on MikroTik. Now, what I'd like to get to is, what is a VPN? So many of you should already be aware that a VPN is short for a virtual private network. And in essence, what a VPN allows us to do is we can configure what we'd like to call a tunnel between two endpoints, between a client and a server, or between two routers in order to route traffic between these two devices. The traffic can vary. It could be stuff like layer 2 stuff, where you generally use something like EOIP, or it could just be layer 3 traffic, like your IP packets that you're routing between networks. VPNs can also be set up in a way to require authentication, and it can also encrypt the traffic. So what that means for us, it means more security. Whenever you encrypt something, it means if somebody was able to get between your two endpoints and they sniff the packets, that they'd only see the tunnel that's been established. They won't actually see what's inside the tunnel, which is very nice. And obviously, if you have authentication, then somebody would need your username or password in order to connect. So just something to be aware of is it's definitely more secure. That's why a lot of people use VPNs to connect. And my last point, it actually just drills down on that. It's commonly used as well to connect through the public internet to access remote content. So this is very useful for us in today's world, where a lot of people work remotely, or it's work from home, or it's hybrid workforces. Because a VPN will allow you as an employee or a staff member a way to access the corporate or the private network where you might have special resources that you need to access as if you were in the office. So that's very useful for us, because now I don't need to go and drive into the office and connect my LAN cable to my laptop in order to get onto the corporate network. I can just connect over the VPN, and now it would be as if I'm in the office, but I'm actually sitting at my house, which is really nice. All right, now I've just listed a few of the common VPN tunnels that you'll see in the MikroTik world, and this is mainly stuff that you'll learn about how to configure. IPsec, they don't really expect you to know how to configure IPsec in the MTCRE, but it is what most people are aware of when they think about VPNs. So you get different types of IPsec tunnels. You get an IPsec tunnel, which is between two routers, where you might route traffic between devices. It might even be between two firewalls, right? Or you could have something called a dial-up VPN tunnel using IPsec, where a user might connect. It's almost like PPTP, where they get a username, password, they connect, and then once they've connected, then the tunnel is established. So IPsec is great for stuff like that. Then the stuff we've covered in the MTCNA, your triple PoE, which is very useful for stuff like fiber to the home or wireless networks, or the good old days with the dial-up. You used to use triple PoE connections a lot then. So triple PoE, still mainstream. You've got stuff like your PPTP and L2TP, as well as the SSTP. I'm actually going to bundle those three together because they all kind of do the same thing, but they also don't. PPTP is kind of legacy, but it still has its uses. And what PPTP tends to do is it uses stuff like GRE to create a connection between two endpoints, but it's still around. It's still kicking. It's still used daily. L2TP is what ISPs tend to use a lot to connect remote sites into an MPLS network, so that you can just put that L2TP interface inside a VRF. And then SSTP is very useful because it kind of allows you to bypass certain restrictions, because many ISPs, they tend to dislike it when you try and use tunneling technologies instead of using their VPN solution. So what they tend to do is they block stuff like PPTP and L2TP, and then somebody very smart was like, okay, cool, if you want to block us that way, then we're just going to set up something called SSTP, which is the Secure Socket Transport Protocol, which works basically on HTTPS. So when the ISP sees the traffic, it looks like browsing traffic. They'll see port 443, but it's actually a tunnel running inside that port that's now connecting to a remote side to form this SSTP tunnel, so that you can still connect to a remote peer or a router to tunnel to them and then exchange information, which is really awesome. And now the two big ones I actually really want to get through in this lecture, because they are going to be a big focus in the exam, is your EOIP, which is a MikroTik proprietary service, and we will discuss it more in detail in a second, but something that you just need to be aware of, it is proprietary. And then we've got IPIP. Now this is one that I don't typically use that much, but it is out and about, and a few people actually ask me about IPIP, but honestly it's not something that I work daily with, so I don't feel like I can answer everything immediately. But what you should understand is what IPIP does. It's similar to SSTP, where instead of it using 443, it's using the IP protocol to encrypt more IP protocols. So it's an IP packet hiding inside an IP packet, so to say. So that's why it's called IPIP. You're creating an IP tunnel inside your normal layer 3 network, and it's just, they just see the layer 3 communications between two routers. And then lastly, we've got GRE. And I just want to mention the GRE, the setup for it works exactly the same as IPIP. So when we set up IPIP, you'll have a good understanding of how to configure GRE. But GRE used to be a protocol that was just used, I actually think it was developed by Cisco. And what it allows you to do is span layer 2, similar like EOIP. EOIP actually also just uses GRE. But you can in essence span stuff like VLANs across a GRE tunnel. You can do some really crazy stuff with it. So that's why people love GRE. And then there's some new cool stuff that's come in with version 7. I just want to give it like an honorable mention, which is the VXLAN, which I've covered in a separate video. And that is definitely, I think, going to start coming in the next exams that MikroTik starts bringing out. But that I'll cover in a version 7 video specifically when it comes to MTCRE. All right, now let's look at EOIP. So this is, again, the Ethernet over IP. And this is a MikroTik proprietary protocol. So what does that mean? It means this works only between MikroTiks. So you're not going to configure an EOIP tunnel from a MikroTik device to a Cisco or to a Juniper or to a Huawei or any other device. You're just going to connect this to other MikroTiks. So this is great for ISPs that mainly just use MikroTiks in their network, because it's easy for them to configure EOIP between their devices. EOIP can run over most layer 3 tunnels. So what this means is if you've got an IPIP or PPTP tunnel, which means there's layer 3 connectivity between two routers, you can also use that as an underlaying network to run EOIP over it. So it becomes an overlay network. It's crazy terminology, but in essence, that's what it does. So you can run EOIP over IPIP, and then you can still use that as a way to bridge connections if you're using stuff like IPIP as well. And interfaces that are created with EOIP can be bridged. So obviously, this is the nice thing about EOIP, is what you could do is you could create an EOIP tunnel between two routers. And this is amazing in a disaster recovery world, or a world where you need to span the layer 2 between two sites. So they're at two physical different locations, but you need them to be able to work in the same broadcast domain. EOIP allows you to do that. So what you could imagine is the routers effectively just becomes two like switches almost, and you are able to bridge an EOIP interface with an actual interface on the router, and then these devices can communicate as if they're in the same broadcast domain. And this will make a lot of sense when we actually go into the lab and configure this, so that you can see what this does and how it works. All right, some more bits about EOIP IP. EOIP IP, just EOIP. Sorry about that. I might cut that out. I might leave it in. Tunnels are configured. So typically you'll set up an EOIP tunnel on MikroTik. You go to the EOIP tab and then you click create or add. A few details you fill in, stuff like a remote address and whatnot, which is really straightforward. But you need to understand that the tunnel IDs needs to be the same on both routers. You can't use separate tunnel IDs, else the tunnel will not establish. And EOIP encapsulates the Ethernet frames inside GRE. So it does make use of protocol 47 for that layer 2 spanning, which is great. And now I just want to talk about IPIP quickly. So IPIP uses RFC 2003, which is basically an open standard. So you could, in theory, use IPIP with any other vendor that uses IPIP as well. Like I said, I rarely use it because I've never had to configure IPIP tunnels in my almost 15 years of networking. So just a heads up, for me, it's a rare thing. Perhaps for other people, it's a very common thing to set up. But what EOIP or what IPIP does, it allows you to create an IP tunnel to a different router so that you can still route traffic as if they were connected to your network. But it's important to note that IPIP cannot be bridged. So you can't take a physical interface and bridge it with IPIP and do what EOIP does. It only allows for layer 3 communication. So IPIP also uses protocol 4. So it's its own protocol. It's not TCP or UDP, it's IPIP. So the last point, creating a tunnel requires addresses of the local and remote routers to be specified on both endpoints. So when you configure IPIP on one device, when you get to the other device, you just basically flip the local and remote addresses around, and then your tunnel should just come up in theory. All right, so this is where I'll end off the lecture bit. Now we're actually just going to head into the lab. We're going to configure EOIP, and we're going to configure IPIP. So let's have some fun with this. All right, so here we go. We're back in our Eve lab. And this is the lab that we set up OSPF on, explained OSPF. So if this looks confusing to you, apologies, but this has been a work in progress throughout the series where we've set up this whole nice ISP network. But I want you guys to just imagine all of this OSPF bits. Just think of this as the internet. I might just move the cloud there. Actually, no, let's leave the cloud there. But just think of that as the internet. What we're going to be focusing on is our site 1 and site 2 on the right hand side, where we have two CPEs. And basically what I want to do is I want these two CPEs to, in essence, connect to each other using tunneling technologies like EOIP, so that it would be as if they were directly connected, so they can route traffic to each other and actually get stuff working. So let's get on to Winbox. So I'm just going to get to Winbox quickly. And let's just use Winbox. And then I'm going to connect onto CPE 2 or CPE 1. Doesn't really matter too much. Let me just connect onto Romon. Let's just find the CPEs. I'm not sure if I've enabled MacTelnet on them yet. So let's just quickly check. Or Romon. Admin blank. Tool Romon export. No, I haven't yet, so that's why this isn't being picked up in Winbox. So let's just quickly do that. Tool Romon set enabled, yes. I also see that the names are wrong, so let's just quickly change them. System identity set name CP1, and let's just fix up the other one as well. System identity set name CPE2. All right, so if I go into my Winbox, I should see them now. So the CPE1 and CPE2 are there. And I will just log onto CPE1 so long, which is this top router. And we are first going to set up EOIP. So that's actually where we're just going to use a single subnet. So let's say we're going to make 192.168.50.0/24 exist at both sites. So I'm just going to delete this other one. Actually, I could have just backspaced that other thing, but let's say this 192.168.50.0/24 subnet, we wanted it to exist at both locations. And we wanted both locations to be able to use a single gateway, which is, let's say, CPE1 as an example. So let's go into CPE1. And then what I want to do is just zoom in quickly. And let's just quickly configure those addresses as well. I don't think I've added this LAN range yet. So that's 192.168.50.0 on Ethernet 2. So let's do that. IP address 192.168.50. Let's make this .1/24 on Ether 2. And then what I want to do to set up EOIP, I'm actually just going to go to my interfaces. I can go to EOIP tunnel. I can click on the plus. Now you can give the EOIP tunnel a name. So I would probably suggest making this something like be descriptive to say where you're connecting to. So I'm just making this to CPE2, but maybe keeping the EOIP bit so that at first glance, if I'm a new administrator, that I know that this is definitely EOIP. Even though it's quick to figure that stuff out, it's always nice to just use proper naming conventions. Now you can set stuff like your remote address, your local address, and your tunnel ID. Now you don't need to specify the local address when configuring EOIP, but it is sort of a nice thing to do. So let's just set that as well. So what I'm going to do is my local address, I'm going to set that as my public, my WAN address, which is this 164.155.6. So that I'm going to make my local address. My remote address is going to be 100.64.155.2 because that is the WAN address of the CPE2 upstairs. So let's do that. And then I've got my tunnel ID, which we need to set as something. So I can make this 1 or I can make it 101. So I'm going to make it 101. And what's pretty cool is you can also use stuff like IPsec to encrypt your EOIP tunnel just to give it an additional layer of security. So something to be aware of. But to bring up the tunnel, you don't need IPsec. It's just an added measure of security for you. So I'm just going to apply this. And now I've got an EOIP tunnel. So if I look at my interfaces, I can actually see an EOIP tunnel that's been configured there. Just also very important to point out, there is going to be MTU limitations when it comes to EOIP. Since it uses GRE as well, there is going to be like 24 bytes that's going to be get sliced from that. So something to be aware of. It means that if your MTU is too small, that you might have some issues with your EOIP tunnels. All right, so let's get back to the configuration. So all that I'm going to do is I'm going to connect onto the other CPE now. So let's get onto, I think it was CPE2. And then on CPE2, I'm just going to zoom in. And let's also just quickly add an IP address. I'm going to make the IP address 192.168.50.2/24. I'm going to apply this. And now I'm also just going to add the EOIP tunnel. So I'll make this EOIP to CPE1. And also what's pretty cool is you can also set the MAC address. So this could come and bite you if you're not careful. If you have an existing MAC address and it's the same, then you might run into some issues, but it's typically never an issue. But just make sure the MAC addresses are unique, but they typically are. All right, so let's set our local address. So in this case, it's going to be 164.155.2. My remote address is going to be 164.155.6, which is CPE1's IP. Now I'm going to set the tunnel ID to 101. And I'll hit apply. And now I should actually see that the tunnel comes up. There should be an R. So I can see the tunnel did connect. So technically the EOIP is up. This is how quick and easy it actually is to set up EOIP. So if I look at my neighbors, I can see on the EOIP tunnel that I've got an address. I can see a MAC address. I can see CPE1. I can even do stuff like MAC ping this, which is crazy. So there exists a EOIP tunnel between the two CPEs now. And if you wanted to, you could add IP addresses on the tunnel interfaces and then route traffic between those tunnel interfaces. But that's not typically what you'll see people using EOIP for. They'll typically be using this to span layer 2 services. So again, I think a point I made was people use this a lot for something like a disaster recovery, where they might have 2 data centers, and you could use EOIP to span a subnet from your primary data center to the secondary data center, and you could bring up something like VMs that are on standby there, and then should the primary DC go down, it's very quick and easy to just fail over to your disaster recovery environment, because you've had this EOIP tunnel pre-configured already. So that's a great use for it. Another use I've seen is if people are busy moving offices and they want to still use the same IP ranges at both sides, then you could in essence do stuff like introduce EOIP to span the network ranges between both offices, so that people can still use their same IPs, the HTTP service can still be wherever it needs to be, and everything will just work. Now, we haven't done the cool bit yet, which is where we need to bridge our networks. But there's one more setting I'd recommend tweaking when it comes to EOIP. So go into our tunnels, and if you go to your... actually, it's the bridge, sorry. So we haven't messed it up yet. So the setting I want to talk about is the STP, because I've also seen STP cause issues with EOIP specifically, where it can cause stuff like a router just going off and coming back on. But let's create a new bridge, and we could just call this the EOIP bridge, and I'm going to apply this. And if we look at the STP settings on the bridge, what I recommend you do if you are using EOIP is just set it to none. You can use like STP with EOIP, and it's definitely probably a good thing to be using. But like I said, I've seen issues with EOIP and bridges. So I'd recommend just setting the protocol mode to none. And from here, it's actually straightforward. Now we can bridge our EOIP tunnel with this bridge interface, and we can bridge the physical LAN interface that we want to bridge across the network onto that bridge as well. Now we've done that on CPE2. Let's quickly get this done on CPE1. So I'll go into this bridge. Also just call this EOIP underscore bridge, or let's just make it underscore BR. Also set my STP to none, and let's add our ports. So I'm going to add my EOIP interface to the bridge, and I'm also going to add my Ether2 to the bridge. Fantastic. So now if I look at my neighbors, I can actually see that I am learning an IP address of 192.168.50.2. Let's see, can I ping that? And I can actually ping the neighbor already, which is really cool and really awesome. So that means these two routers can see each other on their LAN IP addresses. But let's take it a step further. Let's actually do it what people want to test, and test this as if it was from the LAN. So I've got these two VPCs on the right hand side. So I just want to give them IP addresses quickly. So let's just give it an IP of 192.168.50. Let's say 100, with the gateway being 192.168.50.1, which is CPE1's address. So CPE1 will be the gateway. And let's go into this VPC2, and let's do IP 192.168.50.200/24, and again gateway 192.168.50.1. So let's just see from the VPC, can I ping both the gateways 50.1. So that should be pingable because that is directly connected to CPE1. Let's see, can I ping CPE2, which will be across the tunnel. So now VPC2 is pinging via CPE1 across a EOIP tunnel to get to the IP address of CPE2. And now lastly, let's see, can we get to our VPC1? Yay, we can get there. So now we've got a single broadcast domain on two different physical locations using EOIP to span the network. So that is just one use case of EOIP. There's plenty of ways that you can play around with this, because what other people or ISPs might also do is they would use EOIP to span VLANs across their towers and such, so that you can eventually just untag some VLAN to a CPE so that a customer can connect with that. Because again, EOIP, this interface, you can treat it like a normal Ethernet interface. It can span VLANs, it does layer 2. So adding this to a bridge and using that bridge VLAN method of spanning VLANs works perfectly fine. So EOIP, think of this as a virtual Ethernet interface that you've just connected, so you could set up almost like a switching environment between a virtual interface and a real interface to extend a network. So that is the core of EOIP. I hope that makes sense. I think the demonstration was quite practical. If you guys have questions about EOIP, please feel free to leave it in the comments. Now I'm going to move on to the IPIP tunnel. All right, so for IPIP, I'm just going to change the subnet back on CPE1 side to .51. And let's just log on to the CPEs to make sure that we actually have these IP addresses as configured correctly. So I'll make it 51.1. And then on CPE2, it will be 50.1. So I've just updated the IPs to what I want it to be on Ether 2. And let's just disable our EOIP tunnels. So I'll just go into the interfaces and drop the tunnels. So tunnel is being dropped. That was actually expected because I did add an interface to a bridge. So don't freak out too much. Stuff like this does happen a lot. So let's just reconnect quickly. Connect to Romon. Let me get to CPE2. Alrighty, CPE2. Let's zoom in. I might just want to remove these ports from the bridge as well. Alright, so that's CPE2. Let's just quickly check out CPE1. The tunnel's already disabled. Let's just remove the ports or disable them. Actually, let me just remove. And that should be fine. All right, so now let's set up an IPIP tunnel. So this is going to be very straightforward. And again, this tunnel you will be using to route traffic between two different routers or whatever the endpoint is. So we're going to go into our interfaces. Then we're going to go into IP tunnel. Click on the plus. So we can call this IPIP to CPE1. And now here we need to set our local address, which is going to be 164.155. Let me just make sure, .2. And then I'm going to connect to 164.155.6. So the difference here is there is no tunnel ID for me to fill in. And if I click on apply, we can actually see this also does not make use of GRE. So that is why there is more MTU available for us. So that's a nice thing about the IPIP, but again, it doesn't allow us to span the layer 2 stuff. Now, let me just do the same on CPE1. Navigate to the interfaces, go into IP tunnel, call this IPIP to CPE2. Local address 164.155.6, remote address 164.155.2. And let's just apply this. And then we should see the tunnel comes up. It should have a little R there. It should have a little R there. There we go. So the tunnel is up now. And in essence, what we can do now is we could effectively do something like add a route to say, if I want to get to 192.168 50.0/24. I can use my IPIP tunnel to get there. But this is stateless, and it's the same for EOIP and GRE. Those are stateless connections. So you need to make sure if you are routing one side that it is also being routed and being allowed by firewall rules and stuff, like on your return as well. So let's just go into CPE2 and also just add a return route quickly. And then I'll say if I want to get to 192.168.51.0/24, then my gateway will be the EOIP, or sorry, the IPIP tunnel. I like saying EOIP, sorry. So now we've got our static routes enabled. So we could in essence see, can I ping from CPE2? Can I ping 192.168.51.1, which is the LAN address of CPE1? And I can see I'm getting a response to that. So now I'm able to route that layer 3 traffic over this IPIP tunnel that we've established. So this is how IPIP works, and this is mainly what you'll use IPIP for, is just to route between different networks across the IPIP tunnel. And it is really straightforward, as you can see. Like I said, I don't use it at all, and if I barely use it and I can configure this like in one go, and the last time I learned about it was when I went for my MTCRE training, then I think most people can also grasp this. So yeah, this covers the IPIP tunnel, and we've gone over the EOIP. Again, I will put links in the description or in the top comment for the rest of the tunnels, which is the STP, PPPoE, L2TP, and PPTP. I could add them all in this video now, but it would just add unnecessary time for videos that already exist because the information is already there. So please follow the links. I will put it in the playlist as well, so that you can go to those videos specifically looking at how to set up those tunnels. But EOIP and IPIP was mainly what MikroTik is going to be grilling you about. And again, like I said, GRE, it's exactly the same. If you want to set up a GRE tunnel, which is more open standard now these days because a lot of different vendors can use GRE, it's the same as configuring an IPIP tunnel. You just add the GRE tunnel, put in your local and remote address, and there you go. Now you can start doing layer 2 stuff. But GRE is awesome, and it also is a little bit dated, but it's definitely awesome. Anyways, guys, I'd like to thank you for watching the video. I'd like to thank my Patreons and YouTube members for supporting the channel. I've had a blast making this series. I just want to give you guys a heads up on what might be coming next, because I may be interested in adding an MTCRE series, or I may just be continuing stuff working specifically with RouterOS version 7, because that is now the new big thing. RouterOS version 7, I think, is in a very good state right now. It's not perfect yet, but it is definitely where I feel more comfortable working and showcasing it, because I don't feel like stuff is just going to break if I show it to you guys and then you're trying to recreate what I'm doing and then it just doesn't work. So look forward to more RouterOS version 7 content, although I am very tempted to make the MTCRE as well. I might just make MTCRE on RouterOS version 7. So maybe that is a plan. But I'm also in between, doing my own day job as well. So whenever I'm making videos is when I've got time to do it, which is quite rare these days, especially if you're a new dad. So enough complaining from me, but there will be more content coming. I'd like to thank you guys again, and I'll see you guys soon. Bye.